Welcome to my channel, Data 2 Intelligence Pro. Learn Fabric, Power BI, data engineering and analytics, step-by-step tutorials, real-world data solutions, tips to improve your skills, and Fabric.
Work with Lakehouse data. You can load, transfer, and query data in a Lakehouse through several Fabric tools. So in the next few slides, I'm going to discuss about what are the different Fabric tools where we can load the data into Lakehouse. OneLake shortcuts. Access data from external sources, including other tenants through cross-tenant data sharing without copying into the Lakehouse. Shortcuts provide live, read-only references to operational and analytical data across OneLake. Lakehouse Explorer. Browse tables and files, load data, and manage metadata directly in the browser. You can switch between table view or file view and add multiple Lakehouse to the Explorer. In end of this video, I'm going to show you the demo on how to use Lakehouse Explorer. Notebooks. Write Spark code using programming language like Python, Scala, SQL, and R to read, transform, write data to Lakehouse tables and folders. In the upcoming video, we'll explore data with a notebook, and also I'll give a demo on how to load the data using a notebook. The next option available to load the data into Lakehouse is using pipelines. Use the copy activity or other data integration tools to pull data from external sources into the Lakehouse. Run compiled Spark application in Java, Scala, or Python for production grade ETL. Dataflow Gen2. Ingest and prepare data with a low-code visual interface. Lakehouse SQL Analytical Endpoint. When you create a Lakehouse, Fabric automatically generates a SQL Analytical endpoint. This endpoint lets you query delta tables with T-SQL, connect Power BI directly, share read-only access. Query delta tables with T-SQL. Use familiar SQL syntax without setting up a separate warehouse. Share read-only access. Analysts and report builders can query the data without affecting Spark workloads. The last one in SQL Analytic endpoint is connect Power BI directly. Create a Power BI semantic model to build reports on your Lakehouse data. Since September 2025, default semantic models are no longer created automatically when you create a Lakehouse. Existing default semantic models were decoupled from their parent item by November 30, 2025 and became independent semantic model. The SQL Analytics endpoint is read-only and does not support the full T-SQL surfaces of a data warehouse. Use it for exploration, reporting, and ad hoc queries. Let's discuss about multitasking with Lakehouse. The Lakehouse uses a browser tab design that lets you open and switch between multiple items without losing your place. One tab experience in Lakehouse. Preserve running operations. Data loads and uploads continue running when you switch to a different tab. Second one is retain your context. Selected tables, files, and objects stay open when you navigate between the tabs. The third one is non-blocking list reload. The files and tables list refreshes in the background without blocking your work. The fourth one is scope notification. Notification identify which lakehouse they came from so you can track update across tabs. Okay, so far we discussed about Lakehouse. Let's understand what's the difference between Lakehouse and data warehouse. Lakehouse and data warehouse. So the primary development tool in Lakehouse is Apache Spark, which supports other programming languages like Python, Scala, SQL, and R. But in warehouse, the main programming language is T-SQL. In terms of data types, it supports both structured and unstructured, whereas data warehouse supports only structured one. The next one is multi-table transactions. It's not supported in Lakehouse, whereas in data warehouse it supports. The next one is data ingestion. So we already discussed the number of ways of data ingestion into Lakehouse using notebooks, pipelines, data flows, and OneLake shortcuts. But in data warehouse, we have T-SQL in terms of copy into statement, insert statement, CETA statements, and pipelines. The last one, which one is best for? So Lakehouse is very best suitable for data engineering, data science, and modern architecture, whereas data warehouse is mostly used for BI reporting, dimensional modeling, and SQL first teams.
Ingest and transform data in a lakehouse. Your lakehouse needs data before it can deliver insights. Whether you're loading files from local storage, connecting to data across clouds, or building transformation pipelines, understanding ingestion and transformation techniques is essential. Start by creating a lakehouse and exploring the tools available to get your data in and ready for analysis. A lakehouse has two main storage areas and a SQL analytics endpoint. Tables stores Delta Lake tables that provide structured, queryable data. These tables support SQL queries, enforce schemas, and provide ACID transaction guarantees. You can query them through the SQL analytics endpoint and analyze them with Power BI. Files stores raw or semi-structured data files in their native format, CSV, JSON, Parquet, and others. These files don't enforce a schema and provide flexibility for data exploration and processing before transformation into tables. Ingesting data into your lakehouse is the first step in your ETL, extract, transform, load process. Use any of the following methods to bring data into your lakehouse. Upload local files or folders directly through the Lakehouse Explorer. Load to table. Select a file or folder in the Lakehouse Explorer and choose Load to Table to create a Delta table without writing code. This no-code option supports Parquet and CSV files, and lets you append or overwrite data in new or existing tables. Transform data in a lakehouse. Most data requires transformation before loading into tables. You might ingest raw data directly into the files area, then transform and load it into tables. Regardless of your ETL design, you can transform and load data using the same tools available for ingestion. Query data using the SQL Analytics endpoint. The SQL Analytics endpoint provides read-only access to Lakehouse tables using T-SQL queries. This endpoint is automatically created with every lakehouse. It allows you to query tables without affecting the underlying data files. You can write queries to explore data, filter rows, aggregate values, and join tables, just like you would with a traditional SQL database. Common use cases for the SQL Analytics endpoint include ad hoc queries, quickly investigate data to answer business questions. Business intelligence connections, connect tools like Power BI, Excel, or Azure Data Studio to retrieve data for reports. Data validation, verify transformation results after loading or processing data. You can also create SQL views to store reusable query logic. Views are useful when you need to apply business rules, simplify complex joins, or provide curated data for downstream consumers. For example, you might create a view that joins sales and product tables and filters for active products only, making it easier for report authors to consume the data. The SQL Analytics endpoint also supports row-level security and column-level security, so you can control which users see which data when they query through SQL. Query data using Spark notebooks. Notebooks provide a flexible, code-based environment for querying and analyzing Lakehouse data. You can use Spark SQL for SQL-like queries or PySpark for programmatic data manipulation. Notebooks are valuable when you need to perform exploratory data analysis, apply statistical methods, or prepare data for machine learning models. Spark SQL vs PySpark. Spark SQL. Use SQL syntax within a notebook cell to query Lakehouse tables. Write queries like select asterisk from schema table to retrieve and analyze data. PySpark. Use Python code to manipulate data. You can write SQL queries using spark.sql, or use the DataFrame API with Python methods like df, select, and df, filter. Choose the approach that fits your preference and the complexity of your analysis. Spark SQL works well for familiar SQL patterns. PySpark provides greater flexibility for complex transformations and integration with Python libraries. Common use cases for Spark notebooks include exploratory data analysis, investigate patterns, outliers, and relationships in data. Complex transformations, apply business logic that's easier to express in code than SQL. Cross-workspace queries, use the four-part namespace, workspace, lakehouse, schema, table, to join data across multiple lakehouses in a single query. You learned how to create a lakehouse, bring data in through multiple ingestion methods, and query that data using SQL and Spark. Without a lakehouse, organizations often maintain separate systems for flexible file storage and structured analytics, leading to data silos, duplication, and complex integration. A lakehouse in Microsoft Fabric eliminates that divide by combining both capabilities in a single platform, built on OneLake. Dataflows are a cloud-based tool that helps you prepare and transform data without writing code. They provide a low-code interface for ingesting data from hundreds of data sources, transforming your data using 300+ data transformations, and loading the resulting data into multiple destinations. Think of them as your personal data assistant that can connect to hundreds of different data sources, clean up messy data, and deliver it exactly where you need it. Whether you're a citizen or professional developer, Dataflows empower you with a modern data integration experience to ingest, prepare and transform data from a rich set of data sources including databases, data warehouse, lakehouse, real-time data, and more. Dataflow is the newer, more powerful version that works alongside the original Power BI Dataflow. Built using the familiar Power Query experience that's available across several Microsoft products and services such as Excel, Power BI, Power Platform, and Dynamics 365, Dataflow provides enhanced features, better performance, and fast copy capabilities to quickly ingest and transform data. If you're starting fresh, we recommend Dataflow for its enhanced features and better performance. As of April 2026, the option to create new Dataflow items without CI, CD and Git integration support, previously known as Dataflow Classic, is no longer available. All new Dataflows staging Lakehouse items are now created with CI, CD and Git integration support by default. Existing Dataflow items without CI, CD support continue to work as expected. With Dataflows, you can connect to your data, pull information from databases, files, web services, and more. You can also reconnect to recently used sources. Transform your data, clean, filter, combine, and reshape your data using a visual interface. Load data anywhere. Send your transformed data to databases, data warehouses, or cloud storage. Automate the process. Set up schedules so your data stays fresh and up to date. Dataflow Gen2 feels familiar if you've used Power Query before. We have streamlined the process to get you up and running faster. You'll be guided step by step when getting data into your Dataflow, and we've reduced the number of steps needed to create your data flows. Dataflow Gen2 automatically saves your changes as you work. You can step away from your computer, close your browser, or lose internet connection without worrying about losing your progress. When you come back, everything's right where you left it. Once you're done building your Dataflow, you can publish your changes. Publishing saves your work and runs background validations, so you don't have to wait around for everything to check out before moving on to your next task. While Dataflow Gen1 stores transformed data in its own internal storage, which you can access through the Dataflow connector, Dataflow Gen2 gives you the flexibility to use that storage or send your data to different destinations. This flexibility opens up new possibilities. For example, you can use a Dataflow to load data into a lakehouse, then analyze it with a notebook. Load data into an Azure SQL database, then use a pipeline to move it to a data warehouse. Dataflow Gen2 currently supports these destinations: Azure SQL databases, Azure Data Explorer, Custo, Azure Data Lake Gen2, Fabric Lakehouse Tables, Fabric Lakehouse Files, Fabric Warehouse, Fabric KQL Database, Fabric SQL Database, SharePoint Files, Snowflake Database. Dataflow gives you a clearer picture of what's happening with your data refreshes. It has integrated with Monitoring Hub and improved the refresh history experience, so you can track the status and performance of your data flows. Dataflow uses advanced Compute Fabric SQL compute engines to handle large amounts of data efficiently. To make this work, Dataflow creates both Lakehouse and Warehouse items in your workspace and uses them to store and access data, improving performance for all your data flows. Dataflow includes a recent data module that records items you've previously used, such as tables, files, folders, databases, and sheets, and lets you load them directly into the Dataflow editing canvas. You can access recent data from the Power Query ribbon or from the modern Get Data experience, so you can quickly get back to the data you need without reconfiguring your connections. From any recent data entry, you can also select Browse Location to explore and select additional related items within the same folder or database, making it easy to work with multiple resources in the same location. Dataflow integrates with Microsoft Copilot in Fabric to provide AI-powered assistance for creating data integration solutions using natural language prompts. Copilot helps you streamline your Dataflow development process by allowing you to use conversational language to perform data transformations and operations. Get data from sources. Use the Get Data from Starter prompt to connect to various data sources like OData, databases, and files. Transform data with natural language. Apply transformations using conversational prompts such as, only keep European customers. Count the total number of employees by city. Only keep orders whose quantities are above the median value. Create sample data. Use Azure OpenAI to generate sample data for testing and development. Undo operations. Type or select undo to remove the last applied step. Validate and review. Each Copilot action appears as a response card with corresponding steps in the applied steps list. Every data query in your Dataflow can have a data destination. You can only apply destinations to tabular queries. Functions and lists aren't supported. You can set the data destination for each query individually, and you can use different destinations within the same Dataflow. Connecting to the data destination works like connecting to a data source. You can use connections for both reading and writing your data, as long as you have the right permissions on the data source. You'll need to create a new connection or pick an existing one. When you choose a file-based destination, for example, SharePoint, you'll need to configure settings based on the file format you select. When you select delimited text as the file format, configure these settings. File name, the name of the file that gets created in the destination. By default, the file name matches your query name. File origin, the encoding used to create the file in the destination. By default, this is set to 65001, Unicode, UTF-8. Delimiter, the delimiter used to separate values in the file. Options include, colon, comma, default, equals sign, semicolon, space, tab. When you choose to create a new table, Dataflow creates a new table in your data destination during refresh. If the table gets deleted later, if you manually go into the destination and delete it, the Dataflow recreates the table during the next refresh. By default, your table name matches your query name. If your table name has any characters that the destination doesn't support, the table name gets adjusted automatically. For example, many destinations don't support spaces or special characters. For Lakehouse, you have the option to create either files or tables in your Lakehouse. This is unique as most destinations only support one or the other. This allows for more flexibility in how you structure your data in your Lakehouse. Spark notebooks give you full programmatic control over data ingestion. Use Spark libraries to connect to a data source, load data into a data frame, apply transformations, and save the results to a Lakehouse. When you're loading into a new table, automatic settings are turned on by default. If you use automatic settings, Dataflow manages the mapping for you. Data gets replaced at every Dataflow refresh. Any data in the destination is removed. The data in the destination gets replaced with the output data of the data flow. Mapping gets managed for you. When you need to make changes to your data query to add another column or change a data type, mapping gets adjusted automatically for this change when you republish your data flow. You don't have to go into the data destination experience every time you make changes to your data flow, which makes schema changes easy when you republish the data flow. To allow for these schema changes, the table gets dropped and recreated on every data flow refresh. Your data flow refresh might cause the removal of relationships or measures that were added previously to your table. Every data query in your data flow can have a data destination. You can only apply destinations to tabular queries. Functions and lists aren't supported. You can set the data destination for each query individually, and you can use different destinations within the same data flow. When you choose to create a new table, Dataflow creates a new table in your data destination during refresh. If the table gets deleted later, if you manually go into the destination and delete it, the Dataflow recreates the table during the next refresh. By default, your table name matches your query name. If your table name has any characters that the destination doesn't support, the table name gets adjusted automatically. For example, many destinations don't support spaces or special characters. When you configure a data destination for a query in Dataflow, the system performs validation checks to ensure that the destination query is properly configured and can be found. The destination script returns a valid type. Data source references in the destination query are resolved correctly. Only one destination query exists per output. These validation checks run during the publish process and at the start of each refresh operation. If validation fails, the data flow either fails to publish or the refresh operation is blocked until the issue is resolved. The first time you create a data flow in a workspace, Fabric sets up some background items, Lakehouse and Warehouse, that help your data flow run. These items are shared by all data flows in the workspace, and you shouldn't delete them. They're not meant to be used directly and usually aren't visible in your workspace, but you might see them in other places like notebooks or SQL analytics. Look for names that start with Dataflow staging to spot them.